We are going to review 4.1 through 4.3 for your test. So the first thing we're going to do is read the directions. On 1 and 2 we need to find the vertex, the line of symmetry, the maximum or minimum value, the domain, and the range for these functions, and then we're going to graph them. So this first function, if we look at it, we have 1/2 times x plus 4 squared minus 8. Noting the parentheses and this squared out here, that tells me that this is in vertex form. So with it being in vertex form, I can find the vertex by doing opposite of the inside. So opposite of inside the parentheses gives me -4, comma, outside. So my vertex is going to be -4, -8. Opposite of what's here, outside stays the same. Then my line of symmetry is always going to start with x equals, so I can go ahead and put that on both. Line of symmetry is always going to be an x equals, and then it's going to be whatever the x value of your vertex is. So since I found that here, I can just drag it down for line of symmetry. Okay, so when I have parabolas, they either have a minimum or a maximum. If they open up, they have a minimum. If they open down, they have a maximum. Well, how do I know if they open up or if they open down? Well, the way you can tell is your a value. If a is positive, it opens, your parabola will open up. So this one is positive, it will open up, it will look like that, so it has a minimum. So does this have a maximum or a minimum? It's going to have a minimum. Then it wants to know the value of the maximum or minimum. Well, the value of the maximum and minimum, this minimum and maximum will always be your vertex. So since I'm talking about the value of it, I will get that from your vertex. When I'm talking about min and max, I'm talking about up and down. The y is what takes us up and down, so my minimum and maximum value will always be the y value of my vertex. So those two will always match. Domain and range. Hopefully you know domain for all parabolas now. Negative infinity is less than x, which is less than positive infinity. You can also say all real numbers. The range, though, is a little bit trickier. So the range, I want to actually graph this before I do my range. Okay, so I know my vertex is at -4, -8. I'm going to go ahead and graph that. Okay, now when I have a parabola, my pattern for growing is right 1, up 1, right 2, up 4, right 3, up 9, and my mirror points. So left, 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 and those stay up. Now this I need to figure out if it opens, oh, I know it opens up, that's why I drew my arrows up, but I need to find out if I have a vertical stretch or vertical compression. If so, then these ups will change. That is right after the equal sign, my a. So since I have an a of 1/2, that means I'm going to multiply all these ups by 1/2. So this is going to be a vertical compression of 1/2. Okay, I really don't feel like graphing those fractions, so I'm going to go right 4 and up how many? Well, notice all of these were squared to get the second number, so we'll be up 16. If I multiply that by 1/2, I get 8. So I can go right 1 up 1/2, or if I don't want to deal with those fractions, I can go right 2 and up 2, right 3 and up 4.5, or right 4 and up 8. Okay, so notice this is a little wider than normal. Okay, so then my range. To get the range, you put your pen on the bottom of the parabola and work your way up. So if I put mine at the bottom of my parabola, or the bottom of my graph, and work my way up to my parabola, the first thing I hit is this -8. So that tells me that the range is going to be -8, since my parabola is actually touching it, less than or equal to y, which is less than, if I go to the top of my parabola, it'll be arrows, so infinity. Or you can say y is greater than or equal to -8. Now notice -8 was in my vertex, and it's also in my range. It's also my max and min value. So notice it's important that you have your vertex correct, because that then is repeated throughout your problem. Okay, over here I don't have parentheses. I have ax squared plus bx plus c, so this is in standard form. So it'll be a little bit different. In standard form you have to find your vertex, and the way you find your vertex is by finding your line of symmetry. To get the x value, we do opposite b divided by 2a. Opposite b divided by 2 times a. So we have a, b, and c. So opposite my b would be 12 divided by 2 times a, which is -3. So I have 12 divided by -6, which is -2. So my line of symmetry, x equals -2, and the x value of my vertex is -2. Now how do I find the y value if I know the x value is -2? Well, I take my equation, y equals -3 times x squared minus 12 times x minus 6, and I sub in my x value of -2. So when I do this, I'll have y equals 4 times -3, so -12, -12 times -2, so +24, minus 6. So y equals 6. So that will be my y value of my vertex. On this parabola, I notice that my a is negative. When it's negative, it's going to open down. And when it opens down, I am going to have a maximum. And remember, the value of your max and min is always the y value of your vertex. Domain, hopefully you remember, negative infinity is less than x, which is less than positive infinity, or all real numbers. And then my range, again, I find it easier to do range once I graph it. So I'm going to graph it first. So my vertex for this one is at -2, 6. My pattern for growing is over 1, and normally it's up 1, but because my a is -3, I am going to multiply all of my ups by -3. Oh, don't forget here we have and your mirror points on the left. Okay, so all of these were going right and up. Now they're going to go right 1, and instead now they're going to go down 3. Down. Okay, so now write 2 and down 12, and write 3 and down -27, which I'm not going to fit on my graph. Okay, so now I will go right 1 and down 1, 2, 3, and anything I do on the right I have to mirror on the left, and then right 2 and down 12. This is going to be a skinnier little parabola. Make sure you still round at the vertex. Don't make it an absolute value. Okay, now to do range, start at the bottom and work my way up. So the first thing I encounter is arrows, which tell me it's going to start at -infinity. Negative infinity and positive infinity get less than, they do not get equal to, because you cannot be equal to infinity. And then the top of my parabola is at 6, so less than or equal to 6. Or on Math Excel, we would have done this, y is less than or equal to 6. Next one, number 3, rewrite this in vertex form. Okay, well, in order to have vertex form, I'm going to need to find the vertex, yeah? So, to get the vertex, I need to figure out if this is in standard form or vertex form. Well, it's not in vertex form because that's how I need to write it, so it's probably in standard form. In order to find the x value in standard form, find the x value of your vertex, you do opposite b divided by 2a. A is negative 2, b is 12, and c is negative 8. The only two I need are a and b. So this is going to be negative 12 divided by 2 times negative 2. So negative 12 divided by negative 4, which gives me negative divided by negative is a positive, so positive 3. My x value is 3. And now I need to find my y value. So to find the y value, you take the x value and sub it into your equation. So I have y equals negative 2 times x squared plus 12 times x minus 8. Everywhere there was an x, I will sub in a 3. I need to do the work. So 3 squared is 9. 9 times negative 2 is negative 18. 12 times 3 is 36 minus 8. So y is going to equal 10. So in order to write this in vertex form, okay, remember standard form is y equals ax squared plus bx plus c. Vertex form is a x minus h squared plus k. Well, x and y are going to stay. I'm going to need to replace a, h, and k. The vertex is h and k. So where in the world am I going to get that a from? Well, if you look back in standard form, it has an a also. So this a from standard form is going to come replace in vertex form. So I'm going to have y equals the negative 2 from my vertex form, x stays a letter, and h comes from my vertex that I found, and then I'm going to add k, which also comes from my vertex that I found, 10. So x minus the x value squared plus the y value, and we get the a from that original problem. Okay, flip it over. This is my very, very favorite. Finding an equation in standard form passing through these points. So, first thing we need to do is write the equation in standard form using these points. So in this first point, my x is negative 4. So everywhere I see an x here, I'm going to put in a negative 4. And my y is 3. So where I see a y, I'm going to put in a 3. Oops. So it starts with y equals, so 3 equals, then it's a times x squared. Okay, well this will be negative 4 squared, so that's going to be 16. And b times x, so negative 4x plus c. And my second equation, on this one I'm going to use this point. So my y here is negative 6. X is negative 1. Negative 1 squared is 1. So I'll have 1 times a. Hang on, I messed up. Sorry. I replaced the x, so you can't still have an x. Sorry. A, b. Okay. I should write these out. So 3 equals a times 4 squared plus b times 4 plus c. There we go. That's what I did. Negative 6 equals a times negative 1 squared plus b times negative 1 plus c. Okay, so negative 6, negative 1 times negative 1 is 1, 1 times a is a. B times negative 1 is going to be negative b, and then c is not being multiplied by anything. Okay, and this last one, my y value is 10, a times 3 squared plus b times 3 plus c. So my third equation is 10 equals 9a plus 3b plus c. So when we are looking at this, A's I have 16, 1, and 9, B's I have negative 4, negative 1, and 3, and C's I have 1, 1, and 1. So in my opinion, the easiest thing to do would be to cancel your C's, because they will require the least amount of multiplying. Now it looks like to me equation 2 is going to be the easiest to multiply because it has the smallest coefficients. So when I do this, I'm going to use equation 2 on both of them. And I'm going to leave equation 1 exactly how it is, except instead of having this plus a negative 4, I'm just going to make it minus 4. Okay, now equation 2, I am going to multiply it times something that will make my C's cancel. Well, if you look at the C's, I have C plus C. That doesn't cancel. I need them the same number, which they are, but I need them opposite signs. So to make that happen, I'm going to multiply equation 2 times negative 1. So, do I multiply just the C times negative 1? No, I have to multiply every single term times negative 1. So negative 6 will become positive 6, positive A will become negative A, negative B will become positive B, and positive C will become negative C. After I've done that, I'm going to add these together to create my fourth equation. 6 plus 3 is 9, 16a minus a is 15a, and negative 4b plus b is negative 3b. And the c's cancel, which is what I wanted to happen. Now, I've used equation 1 and 2, so I can't use that same combination again. I have to use a different combination, but I really liked equation 2. It was really nice to multiply by. So looking at equation 2 and equation 3, because I'll combine these two now, because I want to use equation 2 still, they have c's that are of the same sign. So again, if I multiply equation 2 by negative 1, I will have opposite signs for my c's and be able to cancel. So I'll leave equation 3 alone. And when I add these two together, I will create my fifth equation, which will say 16 equals 8a plus 4b. Okay, now I need to look. A has a 15 and an 8. B has a 3 and a 4. Now I could cancel 15 and 8, but those are fairly large numbers, and I just don't want to deal with that. So 3 and 4 are smaller numbers, and the smallest multiple I can think of to make them both become would be 12. So I am going to multiply this whole equation, and I'm going to multiply this whole equation. Oh, I don't know why I put the... That's the actual equation. That number in the circle is just helping me name it, not be part of the equation. Okay, so 3 and 4, they both can become 12. To make 3 become 12, I need to multiply it by 4. To make 4 become 12, I need to multiply it by 3. Now if I look at my signs, I have one positive and one negative, so I'm already set up for them to be opposite, so I don't need to make one of my numbers I'm multiplying by negative, because they will already be opposites. If they had the same sign, then one of these numbers that I'm multiplying by would need to be negative. Okay, so my new equation 4, 9 times 4, 36, 15 times 4, 60a, negative 3 times 4, negative 12b. My new equation 5, 16 times 3, 48, 8 times 3, 24a, 4 times 3, 12b. I'll add those together. 84 equals 84a. Okay, well that was handy. So 1 equals a. So now that I have a being 1, I still though need to find b and c. So I can write my equation. So I want to plug a into either 4 or 5 to find b, because you only can solve for one letter at a time. So knowing a, I can only plug it into an equation that has one other letter. So I can't use one of these because they have b and c that I still don't know. These two would only have b that I didn't know. So I'm going to use equation 5 because I can, because I like blue. So 16 equals 8 times 1 plus 4b, and because it's all positives. So 16 equals 8 plus 4b. 8 equals 4b, divide by 4, and b equals 2. Now I'm going to take the a and the b and plug them into one of my originals. I am going to use equation 2 because it is easier. Okay, so how did we get this? We subbed a equals 1 into equation 5. So how are we going to get this one? We are going to sub a equals 1 and b equals 2 into equation, what did I say I was going to use? 2, because it has the least amount of multiplying. Okay, so negative 6 equals a, which I found out over here was 1, minus b, which I found out was 2, so minus 2, plus c. So when I do the math, I have negative 6 equals negative 1 plus c, add 1 to both sides, so c equals negative 5. So now I need to use all of these new things that I found, a, b, and c, to write my equation in standard form. So it's going to be y equals ax squared plus bx plus c. So y equals, a is 1, so you can either write the 1 or you can just skip it and write x squared, because 1 times x squared is still x squared. So to be the most simplified as possible, we wouldn't do times 1. B is 2, and c is negative 5. There's my equation. Y equals x squared plus 2x minus 5. Okay, last one. Number 5. The following table lists the years and sales for the Spaghetti Palace. Find the quadratic regression model that fits this data. Okay, so to do this we need our graphing calculator. First thing we do is turn it on. Second thing we do is enter the data. So to do that you press Stat and enter for edit. Your year will go in L1 and your sales will go in L2 like such. Then to make your graphing calculator give you the model, you'll press Stat, arrow over to Calc, and this says that it is it says find the quadratic regression model. So looking, quadratic regression is 5. Now you won't have this stuff. You might have to make sure yours is L1 and L2, so you would do second 1, comma, second 2. But your calculator won't have this. You'll just have to press enter and then it will show up. So notice it says y equals ax squared plus bx plus c, and this says round to 4 decimal places. So my A is, it's going to say y equals ax squared plus bx plus c. And we need to replace a, b, and c with numbers. So y equals, we start with a, 12.833, and then the next one is 3, followed by a 3, so we do not round, x squared, plus b, which is not a plus, it's a minus 51,249.309. Okay, so then 4 decimals would be 5, and after that is a 2, so we round down, or we stay where it is, the 5. X plus c. C is a rather large number. 1165714.57. Okay. 51,165,714.57. All right. So now it wants me to sketch the scatter plot. So while this quadratic regression is on my screen, I need to press y equals, clear anything that's there, make sure my scatter plot is on. If your scatter plot is not on, you just go up to it, press enter, and back down, and that will turn it on. While that quadratic regression was on my screen, to get it in here I can hit vars, number 5, over to EQ, reg EQ, and it puts it in for me. If I didn't remember those steps, I could just from right here start typing 12.8333. X is right next to your green alpha key, x squared, etc. I could just type in the equation if I can't remember those vars steps. But I did remember them, so I'm going to use that. And then zoom 9 will show me my scatter plot and my quadratic regression. So it looks like I've got 1, 2, 3, 4, 5, 6, 7. So I've got a curve that goes from about here. Oop, that didn't make a very good curve. Goes from about here up to the corner. Looks like my first guy is on the line, a little above the line, or the regression quadratic, under the regression. Okay. Does that look like I matched it pretty well? Close, pretty close. Okay, then it says, use your regression model to predict the sales in 2015. Well, I have a regression equation with y equals and all this stuff. 2015 I can either put in for y or I can put it in for x. So I need to look and see if it's an x or a y. Well, years, I put in L1, so that's my independent variable. These are my x's, these are my y's. So 2015 is a year, so I'm going to plug that in for x. So I'll have y equals, I'm going to put it in pink, 12.8333 times 2015 squared minus 51,249.3095 times 2015 plus 51,165,714.57. Okay, so I can grab my calculator and start typing that stuff in. And you can grab your calculator and start typing that stuff in. or you can use your graphing calculator to do it if you know how to do that. Oops, made a mistake. Okay, and I get 4,441.42. So y equals 4,441.42. So what does that mean? Well, this number is going to be our y, so it's going to be sales. So what that means is that in 2015, because that's what I typed in for x, the Spaghetti Palace had $4,441.42 ooh, that's in thousands. In sales. They had that much in sales.